Coming in as we, volume
It's back there.
Oh, it's back there. Thank you, Kelsey.
Testing the volume. Okay, so we want to start this afternoon off with a panel discussion to kind of go over one of the classes, and it's not certainly, it's a model of how we are addressing some of these issues here with our drone class. And so to do that, we have a panel of, we have a sort of an industry rep, we have students, and we have faculty that have participated from multiple institutions, and primarily JMU, but we have ODU up here as well. And so they're going to talk just a little bit, or we're going to try to get them to talk a little bit about their experience and what that brings to the table for them as students, faculty, and industry. So with no further ado, we'll start off and just, this question was formed for faculty, but I think it's appropriate for students and industry. Tell us a little bit about the course and why it was unique. So any faculty that want to lead off, and then...
And the first time you speak, if you can tell us who you are, that'd be great. It's on.
So I'm Thomas Alberts, and I'm from Old Dominion University. I'm an aerospace engineering professor. And so the course is unique because we have people from different disciplines all in one class, and also professors and students from different disciplines sharing the lectures and the projects. So that's probably the most unique element of it. And also we're talking over video communication. So that's really interesting. It's nice for me because as a professor, I can spend the time to prepare a solid lecture and deliver that, and then the next couple of weeks I don't have to do anything. I can just watch.
Anyone else want to jump in?
Go ahead.
Kevin Dominetti, and very quickly, one of the things that I find unique about it is I'm both a student and a faculty, learning a lot from Thomas and Fred, so it's a really quite enjoyable experience in that way.
So I think it's also important to say, so aeronautic engineering and physics. So that's also important. So go ahead.
Oh, I just got started.
Might be good.
Okay. So I would say that the course is.
So I would say that I'm Nick Sipes. And I'm a major in physics. And,
Right. My name is Nick Sipes. I'm a physics major with a minor in robotics. And I would say the course is really cool because before having this interdisciplinary course, I had only worked with people that thought like me. So when I had to work with people that didn't think like me, it was initially very difficult for me, and I found myself biting my tongue a lot. But then once I opened up to new schools of thought, I found that there are easier ways to go about problems that I had never thought of before. So I think that was a cool thing about the course.
back to faculty.
Well, ditto. I was just going to say exactly what Nick said. It's the interdisciplinary aspect that I think is so powerful, and learning different mind maps and how different people approach different problems is one of the key features to any of these courses. So it's the interdisciplinary nature that makes it exquisitely unique.
And your
And I would say,
discipline,
my name is Patrice Ludwig, and I am a biology professor.
I'm Patrice Ludwig. I'm a biology professor. Yes, thank you for the reminder.
Yeah.
First time calling, long time listening.
Yeah, exactly. I'm first
Okay,
time.
so anybody else want to chime in?
Yeah, hi, my name is Fred Briggs, I work at Nova Labs. I think one of the really unique aspects we didn't get into is the technology we're using in the class. I'm teaching from Nova Labs, which is 2 hours away. Thomas is at Old Dominion University. It's 3 hours away from here, so we have multiple locations simultaneously working together in the class, students from all these locations working together. So, the different technology like Beambot, which is a sort of a robot that will rove around with a screen, so you can actually engage students on a one-on-one basis, even if you're not physically at the location. and add things like WebEx and teleconference equipment. So I think some of the equipment that we're using is relatively unique as well.
Okay, so let's move on to another question then. In terms of positioning students for future employment, what are the benefits of a course like this? Start with you, Drew.
I think some of the benefits would be they're getting exposure to students in different disciplines. They're learning all aspects of the design process. So if you're an engineering student, you're also getting input from, say, a biology student on how you ought to design the experiment. You're getting input from, technical writers and industrial designers. So you have to engage in all aspects of the process, which is what's going to happen as you leave the university. You're not going to just be an engineering student working in an engineering group unless you're, like someone mentioned earlier, sort of pigeonholed in a room at DARPA or something. So I think we reasonably closely replicate what's going to happen in the real world.
I think Sean had.
Actually, I'd like Sarah to answer that question, if that's okay.
So, my name is Sarah Painter. I'm from the School of Writing, Rhetoric, and Technical Communication. And as far as how this class has prepared me for the workplace, I went into this class knowing that I was trying to change my career trajectory. I was originally going to be trying to get a PhD in psychology after graduation. But after working with the team, I thought I was going to basically be a blogger for them, just report on what they were doing. But I ended up taking over internal and external communications, which looked a lot like networking, setting agendas for meetings, running the meetings, and that became project management. And I got a lot of experience learning about this technology. It gave me experience going outside of my comfort zone being writing and psychology and those non-STEM fields, translating those skills that I've learned in those fields into something that is very practical and needed in the STEM world, which is communication and project management and setting goals, reaching them, motivating a team, and going outside of what you already know in order to expand your vision and bring innovative solutions from a different perspective that otherwise might not have been suggested. So.
Okay. So let's go down. We have a student from OU, and I'm going to ask him a question here.
A special question.
So how do you think this course changed your trajectory in your major?
So I guess first off, remember to say my name. My name is Brian Duvall. I'm a PhD student in aerospace engineering at ODU. I originally basically first took the course to kind of help increase my knowledge on UAVs. I've been doing this for a while now, and I guess it kind of answers the first question. Really, is gives me the opportunity to work with other students, like such as, for example, we had electrical engineering students on our team. We didn't have any other disciplines, but it was basically the biggest thing was working with other disciplines and getting their knowledge and input on how to do things within broaden my perspective, and then I can also help broaden their perspective as well.
Okay, so let's ask a faculty then, how do you go about collaborating with 6 or 8 other faculty member teams and some that are from other universities? What's the secret sauce?
I'm not telling you because we're going to try and bottle it and sell it to you. Sean McCarthy, School of Writing, Rhetoric, and Technical Communication. I've been working with this team, or members of this team, for 2 years now, and I come from a humanities background where you're not taught to collaborate as a kind of a de facto default position. You are taught to be a solo researcher. So it's building up a lot of trust between the group. But back to Fred's point, that the communication technologies are really, really important in making all of this fluid. The Beanbot kind of brings a presence into the room in a really interesting way. We use a professional messaging service called Slack, which we can see the complete dashboard of what all the projects are doing, and it gives the students a way to learn how to be on teams in a kind of distributed sort of way. And yeah, so the technology is important, but I think as well that the team builds up a lot of trust among each other about how to run a course that can change a lot between week to week. So Thomas and I never had actually met before we actually collaborated, and we ended up, trying to do some writing with these guys, very successfully for the most part. But we had to kind of trust each other's expertise and being able to get that done and communicate, and to get on with it even when the communication didn't work, which often happens too. So I think trust is a really important part of it. But I think finally, I think part of the reason why this works is that everyone gets energized about working on these projects, right? We're doing something really interesting with the technology, and the mix of disciplines in the room leads to a very positive kind of collaborative energy that is really important to making what would otherwise could be disastrous. If you've got this many disciplines and this many people from all over different campuses working together, it should be a disaster by just traditional logic, but it works. And I think it works because we develop a rapport very quickly, and that's a big part of it.
Kevin Dometti again. I consider myself an open-minded skeptic. So when I stepped into the room the very first day, and I had these people talking about how we were going to run the class, I had to bite my tongue a little bit and kind of see as it went how powerful the other disciplines could be, both helping my students, my physics majors, as well as broadening, indeed, my own perspective on how these projects develop.
So maybe Kiva, we haven't heard from you, so how about talk about it from a student's perspective, working with multiple disciplines and faculty from around the state.
Sure. Sorry. So my name is Kiva Gale, and I'm an integrated science and technology major. And honestly, part of the reason why I took this course was because I wanted to work with other people that were outside of my major. Because I'm from a major where we often work in teams. All of our classes and all of our courses are geared towards a team environment and learning how to work with other people. But I'm not used to working with other people. You okay?
Yeah, I'm fine.
I'm not used to working with other people that were outside of my major and outside of my mindset. And so working with someone who is on the other field of technology, like writing, and someone from health sciences, and someone from physics, it's really broadens the way that I think and how I think and how I, as a person, approach challenges. That's a little bit differently than what I've learned being taught as an integrated science and technology major. And it has really helped me grow and develop as a student.
So we have a couple of folks here that haven't had a chance yet. So do you think a course like this will help you in your future employment, finding and contributing to your employer?
Matthew True, a health science major. Well, I'm a health science major, so I'll be working in healthcare. So for me, it's not so much being in the class, but what I learned in the class, collaborating with an interdisciplinary team, as Kiva said. I think that experience is really going to help me. Teamwork is huge in healthcare, and yeah, I think that's probably the biggest help.
Okay. You want to address the same question?
Yeah. Hi, I'm Quivo Sullivan, and I'm a double major in writing, rhetoric, and technical communication, as well as industrial design. Future career-wise, I think that we're in a pretty unique situation because from this class, we've been able to develop a potential and burgeoning business. So in that very direct sense, for my immediate career, it's definitely going to help out in terms of where we're going. And I think a lot of people have high hopes considering the context of this class. But also, I guess in the future, I think as a designer and a writer, it helped me kind of see the full scope of a project, not just as I'm immediately working on putting this drone together or the post-processing of what I'm doing with it, but what happens when you get there and something goes wrong? And then how do you react from that? And how do you anticipate those kind of situations and establish options for how you're going to approach a problem?
Yeah. I would like to give a specific example of what it's like to work in an interdisciplinary way and how those different mindsets think differently. In our first brainstorming session, we started thinking about what are we going to do. We were.
Why don't you tell them about your project?
We were creating a 3D model of a historic wall in Colombia as part of a conservation project, some research that a PhD student was doing down there. And so our physics and ISAT majors started coming up with some technical thoughts about what that's going to mean, talking about LiDAR and other methods that they might use. Quiva and I were talking about, what is this going to socially mean? How does the wall interact with the community? And I think for them at first, they were a little bit put off. They were a little unsure of what are these people talking about and is this relevant? As we started moving forward in that collaboration, we both began to highly value the perspectives that we bring. They obviously, we could not have done it without their technical information. That is vital. But I think that they also came to appreciate the other perspectives that we bring that might otherwise not be there. And as Quiva was saying, when we got on the site, we had challenges to overcome. If it had maybe just been, oh, I know how to operate a drone, I know how to operate software, Quiva became a vital part in the execution of the project because there were major challenges, environmental challenges of the wind really whipping our drone around, her ability to come up with innovative solutions to that was a type of thinking that was completely important to getting our work done. So the different perspectives that are brought in have been immensely impactful.
So what was the solution?
The solution was, does someone else want to, yeah.
Hi, Quiva again. Yeah, so as she was saying, we kind of had to adapt. We got there on the first day when we were kind of on site. We realized the scope of the project was big, and when we started to realize that the wind speeds were just uncharacteristically high for the environment, we were like, okay, we can try this again, or we can walk the wall and see what kind of video we get, because to kind of re-elaborate, we were taking video of the wall that we would then put into, we put into Photoshop and put it into picture frames and then stitch together in a program called Agisoft for photo stitching. So long story short, we got there and we realized, well, the drone's not going to be able to get all these different angles for us. It's not going to be so easy to get several hundred feet of wall video-wise. So we spent the better part of 2 days and all of one day just walking the wall. We bought selfie sticks because so many people on the street sold them there that it just seemed like the best tool we could take. So we bought selfie sticks and we got tape measures because without the drone and without Mission Planner, which was helping us to maintain a specific distance and accounting for all these different measurements, we had to do it by hand. So the 6 of us split up into 2 groups, and one person was kind of directing on one side of the wall, the other person was directing on the other side, and then the other one was measuring, and then the other was filming. So we got low angles of perspective, high angles of perspective, and then went to the top and back of the walls. And it was a really extensive process, and it shows why the drone is such a good solution. But in the end, I'm pretty happy with the work we did, and in the process of making it into a model now that I think that our PhD candidate is going to be really happy with, and in making adjustments to the drone, we'll be able to hopefully use it and complete the rest of the wall into a 3D model as well.
So one of the purposes of the conference is to bring industry and curriculum together. And so one of the questions that I think we really didn't ask is, how important is it to you as faculty and our industry rep and students to have real and relevant problems and projects that you're working on that have sort of a timeliness to them? And so I'll just open it up if anybody wants to comment.
Sykes first.
Thanks. Nick Sykes again. I would say that if the projects we were given weren't actually real from a personal perspective, I would put a lot less effort into it, because it's almost like you're telling me that we want you to think of this way, but we don't actually put enough faith into you to come up with something, so we're just going to kind of give you a applied solution or something like that might help one day, but we don't actually expect you to come up with anything substantial. So that it's kind of, we're just spinning our wheels for 16 weeks, and then we come up with something and you go, oh great, that's cool. Now let's give it to somebody who can actually do something about it. So I mean, that sounds a little aggressive, but I think as a student, I like it when faculty members give us responsibility and they show faith in us and they give us resources because they believe that we can actually do something with it, and not that we're just here to learn processes and all those kinds of things.
That was kind of my answer too, just from the faculty perspective, but it changes, and I'd say all of us probably agree that it changes the stakes of the entire classroom experience. We've also built a kind of a publicity machine into the project in that on the first week we tell the students you're going to be presenting your project publicly on the last day, and there'll be a whole kind of media machine around it, and it kind of terrifies them first, but it gives them the push to really excel at what they're doing. And there's just no substitute for a real project. From my perspective, there's just no substitute for a simulation. As Nick says, is a simulation at the end of the day, and you don't break that fourth wall, right? But when you are actually working with a collaborator who needs a solution to something, when you are going to put your faith in a group of people to say that what I come up with is going to be valuable and I am going to be proud to present it to whoever is going to walk into the room, that changes the entire experience, both for the students and the faculty, because we interact differently. The faculty become collaborators rather than holding all the knowledge and then we're just teaching the students. We actually don't know what the solution is going to be either. So we become collaborators, we develop that trust, and we just have to push it that bit further, which is, it's a kind of an intangible quality, but the thing that guarantees that quality is the reality that you're faced with at the end of the 16 weeks. And anything, yeah, I mean, that's really it.
I'm Patrice Ludwig, I remember. One of the things I think is really important in this conversation is, Nick, you're a senior, right?
Right.
So one of the things that I think I have to kind of remember all the time is that there's important scaffolding that has to happen, and you come from doing projects in your major, and people come from working in teams in their majors. So one of the important curricular aspects of these types of classes is having the classes for the sophomores and having the classes for the freshmen that introduce these concepts, where it is okay to go through process only and you don't necessarily have a high stakes outcome, so some lower stakes process learning that preps them for these high stakes capstone kinds of experiences. And I think that's one of the things that as we go forward in developing our co-curricular activities, that's a really important aspect to keep in mind.
Hi, I'm Kiva. And also as a student, to just build upon that, it also really helps develop passion. Because if you're given a problem that has a real world effect to it, it becomes a part of you. You become really invested in it to make a difference because you know that you can, and you have faculty and you have other students that are pushing you to show that you can actually do this. And even if it's just a semester thing, it can also be something that builds past the semester, that turns into a career, that's something that you really want to pursue. And I'm a junior, so I'm going to be here another year, but because of this project, I have discovered my passion for drones and discovered my passion for using this kind of technology to solve real-world problems, because I know that we can. I had the experience of this project and actually being able to test it in the real world to know that the things that I do are possible. So that's pretty big.
So Thomas, you guys did Fred, if you want to speak, but Thomas, you did a little bit different project, so Fred, you want to speak? And then,
yeah, so one of the projects that we found was that, I see a bunch of firemen up here, so we had a, the Columbia Fire Department, Columbia North Fire Department.
Oh, okay.
We didn't score high enough on the
They said it, I didn't.
So anyway, I think the students come in and they think they're going to have fun flying drones, but they end up getting engaged in this project and they start loving the project. And I feel like we really helped the Corolla Fire Department with their drones program, and the students loved that. You know, we went down there and flew with them and helped them, you know, learn how to fly and everything. And so that was very rewarding to all of us, I think.
yeah, tell them just a little bit about your project, the one with the fire department.
Well, they wanted to use drones for various things, search and rescue, and also for spotting fires. And so one of the things, they had a drone that kept crashing, and so we were trying to figure out why it would crash. So we took it and put some sensors on it that could record the data, and then we just went and flew it there, and it crashed. And we took the data, and it turned out it was just a bad ESC that was intermittently failing, but they would never figure that out. So that was, one of the aspects of it that we did. And then we built a waterproof drone for them because they have to fly out, and they always have reports of floating objects in the ocean, and they have to go and investigate that and see if there's a person on the object, or if it is a person or not. And then if it's just a floating object that's just junk, they can leave it alone. If it's a person, then they send a boat. So that was another part of our project.
Okay, so I guess we can. Any other comments from the panel? I think we have a couple minutes left. If anybody has any questions they want to ask from the audience.
So how did you decide? You had two different projects?
Well, there are actually 5 projects at JMU and three at ODU and 1 at George Mason.
So how did you decide to write page for it? So who was the lead? Who were the contributors? How did you actually write separate papers?
No, they created drones. They
Just totally correct.
They worked with their client to create a drone to solve the problem. So the problem was described as sort of like what we did for what we're doing now for Hack for Defense. The sponsor said, "Here's our problem, and we need help, and it's kind of beyond our technology. We're not able to solve that problem. So can you help us?" So they actually had real clients throughout, and I think it was sort of for the most of the team from JMU, the students, when they found out that their project sponsor was in Colombia, South America, and that they were going to take whatever their deliverable was down there and test it for the first time, I think that, did it wake up? It was a little... sort of became real for them. So yeah, it was not about writing papers. They did write blog posts and stuff.
But academically, we are, like from the faculty side, we're studying these outcomes. So there is paper writing that will go out to the academics out there to say these are the measured learning outcomes. This is how we know that students are achieving what we think that they're achieving. And that's also a very collaborative process.
And the students are writing all the time. So there's, they're writing on the messaging system, and they're also writing a blog. So every week, and that's kind of my job, is to create a prompt for them. Say Professor Alberts gives a lecture, then they have to write a report on the lecture, but for a general audience. So they have to translate technical concepts for different kinds of audiences, come up with mission statements, come up with press releases. So they have to really think around the project through all these different writing genres, which helps them understand. That's where a lot of the interdisciplinary learning actually happens, through the collaboration on the writing. So Sarah might be writing the blog post, but has no idea what the physics concept is. So Nick has to explain what it is, so that they can actually come up with the articulation of the problem.
And so next time we teach this course will be in the spring. So it's a year from now, basically. And we will have to enlist a set of clients who see an opportunity for our students to address an issue which perhaps you have not been able to solve, or you just want different minds working on the problem. And then you'll have the support of faculty at JMU, and from Fred and Chris from Nova Labs, and maybe some other universities that join in. So we will be looking for clients to do exactly that. And then you'll make your pitch to the student groups, and then they will decide what particular project they would like to work on. So it's an opportunity for businesses, and like I think the police had this year did one, right? That was.
Well, it was a fire department for.
Fire department for them, but did JMU ever want us to do some? No, okay.
No.
I thought
They're welcome to.
Yeah. Because there's lots of things where you think, boy, if I don't have to do it, but I could get some students to do it, I'd love to have this done.
So it sounds like clearly it went very well, but I'm wondering, what would you do differently next time? What would you change? Lessons learned?
It's like
Yep.
telecommuting, I guess, just in terms of, I guess, the kind of the audio visual problem we have, maybe just improvement on that. I know from OU, the site that we were using probably wasn't particularly the best site. It's just probably that'd be the main thing. It's just changing kind of the tech behind the scenes kind of things.
But from a class organization, like how would we design the class better to have greater impact? I think is the question. So that was a technical. So we get the PhD engineer, it goes right to the technical solution. But from a just an overall perspective, what could we do better?
Something Thomas and I have been talking about is the difficulty of, we only have a 3-hour period for the entire week. So it was difficult to find time to address, there was 3 different campuses all tuning in at the same time, but then we had audio-visual problems, which were, sometimes the technology didn't work, there was feedback, or we couldn't get logged on, or whatever. So that is a problem. Beyond the technical issues, I'd like to try and create a way where I could be on a separate video channel, for example, doing a quick writing prompt with students at ODU at some stage during that 3 hours. In other words, to maybe micromanage the 3-hour period such that there was more coverage, because it's difficult to squish, is that a word? To squish everything into a 3-hour period when you've got lots of different the projects are emerging, so there's lots of new things to deal with every week, but there's also core skills that we've got to try and push across 3 different campuses at the same time. So I think I'd be interested in kind of being able to stake out, like, I want 20 minutes, I'm getting my 20 minutes.
So I think also where JMU was multidisciplinary, ODU and GMU were both pretty narrowly focused, and they may not have been all the same major, but they were pretty close.
Yeah, so I've taught, this is the 3rd time I'm teaching, and so far the furthest I've gotten interdisciplinary is to get electrical engineering involved. Although I had, actually, I see George McLeod back there. He helped us with the tidal flooding project. So I think eventually we'll get more, I would really like, my goal is to get more students from other departments besides just engineering departments. But that's a challenge.
Yeah, so one of the missions of 4VA was to leverage the strengths of the universities in Virginia to do more than we could do on our own. And so we don't have an aeronautic engineering program. So and we don't have George Mason has a really developed computer science and gaming industry program that we were able to bring in with a different perspective. And so bringing in those different perspectives and for majors that we don't have, really I think adds a level of sophistication, and also the virtual team. And there are a lot of companies that do virtual teams all the time, and so these guys are really. I won't say they're experts at it, but they really understand a lot more about what that means than your average college student does. So
maybe that could be a challenge for the next time, is to try and share across the campuses. Have a team that's made up of students from ODU and
so that was really my original goal, and when you start to put it together, it's like, oh my God, that's just too hard. So that's a real goal, is to have like writing students at JMU and engineering students at GMU and aeronautic engineering students at ODU all working together on the same project. But it gets hard because the physical object that you're creating only exists in one location, and so the writing students trying to write about something they've never seen, that's a level of sophistication that is pretty. I can't get my head around it quite yet, but maybe we'll get there. Maybe we'll get there. Any other questions from the field? Yeah.
It's not really a question. My name is Scott Fellows. I'm from the Virginia Space Grant Consortium, and I'm part of the geospatial effort that we have down there, but I also run an internship program for students just like yourselves, STEM students, all across Virginia, and I encourage, I'm not getting into a whole lot of detail, if you're interested in an internship in your field in Virginia, and an application that continues to survive as long as you're an undergrad and you pass being an undergrad, I'd encourage you to try to get in touch with me before this is over with, and the same with any companies that made internships. There's no cost for any of this, so throwing your hat in the ring, getting an application into maybe a bunch of companies.
Thank you.
Thanks.
So, I'll also say, we have
on the
a,
table, I think.
we do have representation from Liberty and from Embry-Riddle. So I can hand you the mic, or you can just, so if you guys, aside from just having the industry, looking at, fire rescue or Booz Allen's here, so aside from the industry reps, also bringing other universities in, we're absolutely open to that, and I've talked to you a little bit about that. So I think we're
You're good? We
good
can
on
gain
time.
back some time.
okay. So yeah.
I mean, just a quick observation. It's really interesting. I love everything that I've been hearing. This is incredible. It's a great opportunity for all universities. Yeah, I'm John Walker from Liberty. And yeah, just an incredible, this is awesome. I love this because I always think back to when I was a student, which wasn't that long ago. I realize I'm pretty young. And I think this would have been something I would have loved to have done as a student. The interesting thought from my perspective, sitting here hearing your project, and then what you ran into when you went down there, I have 60 unmanned aircraft systems operator students at Liberty University who are dying for a real world project to be a part of, and their background is aviation, and one of the classes they take is meteorology, and in that class they learn about winds, and then they come to my class and we do small UAS flying, and I take them up in winds that are too much for an aircraft, and I mean, just some of the applied knowledge some of them have, and maybe there isn't a direct application. It's a very engineering heavy, and I understand, and I do understand we have a different sort of niche where we're at. We're not engineering, but are those skill sets, is that knowledge set very useful, and at what level is it useful? You know what I'm saying? Like that's I think where the conversation I'd love to have it. But yeah.
So I think to start with, I'd say we don't know. And when we brought in Thomas, we didn't know how that was going to work out. But we find somebody out there that's willing to. So you got to be really willing to work with ambiguity, right? So I think that's probably something that everybody up here would agree with. This is not a normal class. Some of the students got a little bit anxious because what's the grading rubric? That's what they've learned that since they started first grade with SOLs. What's the grading rubric? And well, yeah, there really isn't one yet. And so working through all those things, and from faculty, it's the same problem. I mean, you're really asking these guys to work with ambiguity. So if you're willing to work with ambiguity, Thomas, I think the first semester you went through, it was not you kind of were observing, and then you said, okay, I have expertise in this, and I saw it last time, and I think I can add to that. And everybody else said, great, because that's one class they don't have to teach. And so I think there's some real collaboration opportunities that will open up there. Darren?
Nick, I just wanted to go on with what Ron was saying there. Aaron Goodbar from UCC. I just go along with that. It's that if y'all guys reach out to industry experts that may be beyond your skill set, as an example with the wall situation there, did you talk to surveyors or anything like that that would do this on a day-to-day basis prior to going to that location? Or did you have surveyors from Columbia meet you there? Anybody that has done, or structural engineers as an example, where do you say, at what point along the way, or do you say, hey, we might need to bring in some outside help at professional level? If you need an expert pilot in 25 knot winds, well, we call Jonathan and have one of the students come down and assist and collaborate. Is there a point where you say, okay, we're still learning, but we do see the need for expert help inside the situation?
Yeah, actually, I think that's part of their discovery process. So yes, I think as sort of novice problem solvers, I'd say you don't always know what you don't know.
Right.
And so I think that's a really important part. It's like you don't know that you could talk to a surveyor that's the kind of knowledge that they could bring in. So
is there an opportunity for us to, or industries within Virginia to sign up and say, hey, we have this expertise, that
absolutely,
on?
absolutely.
I mean, we do it in Boy Scouts all the time. Say, hey,
right.
We know this stuff.
Right, absolutely.
There's an opportunity there for that. I see a lot of great
That's a great way for industry to interact. Yep.
Senator Harry Gregori, Virginia UAS. Thank you, Harry Gregori, Virginia UAS. Just also want to commend your projects, because we heard this morning a lot of comments about problem solving as a shortfall in terms of people coming into the industry. So this is a really great example, and I love what happened to you because that's real life on the wall project. And the great part is, you know, it's the pay-in. You get paid to get a project done, and things always don't work right. So that was terrific. That was excellent. Somebody needs to write that up. Thank you.
Did you want to say?
So, one quick note. All right, so we've painted, hey Taylor, Jamie, we've painted this really rosy picture of the class. It seems, and I've got to be the naysayer, it's not that perfect. There are ways to improve it, but I want to point out how difficult it can be. Nick and some of the other students touched on it. While there's positives for having all the different students with their different opinions and their different ways of looking at it, it can also be a negative at the same time. And to watch you guys go through the process of conflict resolution with the different groups was really fascinating. We, you know, a couple of faculty got together last night and talked about it. We're like, you know, that Slack program that you guys worked on together, you were all so polite in dealing with each other as you're going through, hey, you missed the meeting for this. When are we going to reschedule that? Hey, your part is behind by a week. You know, we're supposed to be at this point at this time, and we're not there yet. And you can see the agitation growing a little bit as they're going through it. But they really developed some good conflict resolution skills, and I'm sure a myriad of other, you know, positives in there, things you learned to deal with the different groups that just, you know, you get so many different perspectives on a project. So it's not always perfect, but it was really great to see the way they worked through it. You guys got more on that? Because I know you guys, I watched the groups, and it was great watching the communications that went through with that.
Yeah, I would say that, thanks. I would say that as much as we learned other schools of thought and those kinds of things with other people, we learned how to deal with each other. And I think a lot of industries or whatever group project you work on, if you can't deal with the people you're working with, then more often than not, it will not succeed. So that was probably, when we started the semester with the project, I was not a very good team player, and I told myself, I'm going to be the best one there, and I'm going to work the hardest at it to be a good team player. And by the end of the class, I actually found myself not having to force myself anymore to be a team player. It just kind of came naturally. So yeah, that was a good thing to bring up. Thanks.
She's going to agree he was not a great player.
Yeah, I've known Nick the longest, so I have to say that what he said was true. But something else that we didn't necessarily plan was when we got down there and we had to face the fact that the winds were really hard and to come up with alternative solutions, that we were in high stress situations, and we weren't in high stress situations like that before. And having to work with each other when things weren't going right and you had a strict time limit and you still needed to produce something, it definitely brought a lot of tension to the group. But at the same time, we've been working with each other for a while, and we're like, okay guys, we're here. Like, getting angry at each other because something's not working is not going to help us get anywhere at all. We need to sit down, we need to figure out what's going on, we need to talk through it, we need to come up with a plan to have a deliverable by the end of the day. And we did, and just even though that we had, you know, some slight agitation while we were down in Columbia where things weren't exactly working according to plan, we were still able to come together in the end and get a deliverable, and we still loved each other by the end of the trip, so that was a good thing.
So coming into this, I think that many students feel this way, that group projects can be the worst sometimes. Coming out of this, I had to say, wow, this was my best experience ever working with a group. My psychology background has informed a little bit about what happened between us. We had a lot of group cohesion. So that we met in my house. We had snacks. We hung out with each other for fun outside of class because we like hanging out together. We trust each other. We all took ownership of the industry or the backgrounds that we represent. So I had to trust my other team members to do their work because I couldn't do it without them. In other group projects, I think that there's some micromanaging, like maybe I could do all of this, but I'm just going to delegate it. The fact that it was so interdisciplinary meant that we had to trust each other. So that created a lot of trust and a lot of cohesion within our team. So even in moments where it was frustrating, we needed each other, we liked each other, and we worked through it. So I think that was a very positive experience.
I will say that that's exactly what the faculty do too. I mean, that is an entirely parallel process. We go through the exact same thing, 100%. We hang out together, we bond together, we trust what everybody is doing. It's the exact same process. Go on.
Christy here from Everett. So you have a lot of brain power for solutions. Where did you go to find the problems? How did you locate someone that would be an end user for your class?
Another part of 4VA is collaborative research, and so I see a lot of collaborative research project applications come in, and when those projects come in, I sort of was able to go out and tap those folks for problems. I know you have a problem, and I think Thomas the same thing at ODU. Folks came to him and said, "Hey, you're an expert on this. Can you help?" So it was a little different aspect. I think the city walls was a different one. So the project that they worked on was a different one. It's just by chance I got to go to Columbia and these guys brought up this project and so that came up. But the other projects were with researchers at JMU. We have a landmine center. I know that's not necessarily logical. Like we don't have a huge landmine problem in Harrisonburg or Virginia, but we do have a Center for International Stabilization and Recovery that's located here, and so the international problem with discovering landmines and then clearing them is a problem that really resonates with the students. So that's a problem that really is recurring. We've done two classes on it. Patrice is a biologist, and so there are a lot of potential biology applications with vegetation and aquatic situations that we can address with drones maybe more efficiently. And so it's through those kinds of circumstances that we've done it. But that's where getting the word out that this is going on and trying to get industry in. Not every, a drone is not the solution to everything, but these kinds of real and relevant problems coming into the university, so we can hand them off to it comes in, it's not, okay, that's great, but it's not a problem that we can handle with the drones, but maybe the College of Integrated Science and Engineering now, MGO, it's something they can handle. And that has happened as well. So the last conference, Dick Ship came in with a problem, and it was not a drone issue, it was really an engineering issue. So the engineers are working on that problem. So I think that this draws attention. It draws people in, and then we can funnel that out. And I think that's it creates a nice avenue for the industry and the institution to work well together. So institutions to work well together. We're good.
We're good.
Any other questions from the audience? Any final comments from the panel of this?
Yeah, Cleva again. I'd just like to make one. I think in hindsight, yes, of course we've looked at this with rose-colored glasses, but I think it's also a really great measure of how progressive this university is, especially for VA and the programs here, because this kind of is the way that education is going, multidisciplinary, actualized projects. And I think that is some huge takeaway for all of us, because we've spent an entire semester working on something we actually got to do. And there's nothing wrong with theory, but I think as you get to more corporate and legislative levels, problem solving becomes more challenging because there's more barriers. But in education, we have a little more freedom. And as students, I think we can solve oftentimes without risk. And then if we can solve without risk, it makes everything a little bit easier going forward. So I think I'd just like to say thank you, because it was an awesome opportunity and a really fantastic class. So thank you so much.
Nice close.
That was not a paid.